When estimating electrical materials for residential projects, several free and affordable programs are available. These tools can help you create more accurate bids, manage cost effectively, and ensure you have the right materials for the job. Firstly, the Electrical Estimator by Home Depot offers a free online tool that allows you to estimate the materials needed for various electrical projects. This tool is user-friendly and provides a basic overview of the costs associated with different electrical tasks. Secondly, the Electrical Material Cost Calculator by Buildwith provides another free online resource for estimating electrical material costs. This calculator allows you to input specific project details and receive an estimate of the materials required. Thirdly, the Electrical Supply Calculator by Klein Tools is a free tool designed to help electricians and homeowners estimate the electrical supplies needed for a project. It includes various calculators for different types of electrical work. In addition to these free options, some very cheap estimation programs are available for more detailed and professional estimates. Firstly, Estimate 101 offers a single user license for around $49. This program provides a more comprehensive estimating solution with features suitable for smaller projects. Secondly, Electrical Pro Estimator offers a single user license for around $99. It includes advanced features such as customizable databases, report generation, and integration with other construction management software. Thirdly, electrical estimating software by Fastrax is available for a single user license for around $149. This software provides a more robust set of features for detailed electrical estimating, including the ability to create and manage complex projects. To enhance accuracy and save on costs, consider these additional tips. Contact local electrical supply distributors for pricing and estimation assistance. Building relationships with suppliers can provide access to competitive pricing and valuable insights into material costs. Use online resources such as RSMeans or SDCom to research material costs. These platforms offer extensive databases of construction costs, including detailed information on electrical materials. Consider using a spreadsheet or other software to create a custom estimation tool. Tailoring an estimation tool to specific needs can improve efficiency and accuracy. Reach out to local electricians or electrical contractors for professional guidance. Seeking expert advice can help identify potential issues and ensure the estimation is thorough and accurate. When utilizing electrical estimating software, understanding the different components and functionalities can significantly improve the estimation process. Some programs offer features such as customizable databases, which allow you to input specific pricing and product information relevant to project. This feature is particularly useful for maintaining accurate and up-to-date cost data. Many electrical estimating programs include pre-built databases that contain information on a wide range of electrical materials and components. These databases can be customized to reflect the specific pricing and availability of materials in your area. Report generation is another important feature to look for in electrical estimating software. This feature allows you to create detailed reports that summarize the estimated costs for a project. These reports can be used to present bids to clients, track expenses, and manage budgets. Integration with other construction management software can streamline the estimating process and improve overall project management. Some electrical estimating programs can integrate with accounting software, project scheduling software, and other tools commonly used in the construction industry. This integration can help you avoid data entry errors, improve communication between team members, and ensure that projects are completed on time and within budget. When using free estimation programs, it is important to be aware of their limitations. These programs typically offer basic functionality and may not include all of the features found in more advanced paid software. However, they can still be a valuable tool for estimating simple residential electrical projects. Before starting the estimation process, gather as much information as possible about the project. This includes blueprints, specifications, and any other relevant documents. The more information you have, the more accurate your estimate will be. Break down the project into smaller, more manageable tasks. This will make it easier to estimate the materials and labor required for each task. Use consistent units of measurement when estimating materials. This will help you avoid errors and ensure that your estimate is accurate. Double-check your calculations to ensure that they're correct. Even a small error can have a significant impact on the overall cost of the project. Consider adding a contingency to your estimate to account for unexpected costs. This will help you avoid going over budget if unforeseen problems arise. Keep track of your actual costs as the project progresses. This will help you identify areas where you can improve your estimating skills. Electrical estimating is a complex process that requires attention to detail and a thorough understanding of electrical systems. By following these tips and utilizing the available tools and resources, you can improve the accuracy of your estimates and ensure that your projects are completed successfully. Consider the labor costs associated with the project. Labor costs can vary depending on the location, the complexity of the project, and the experience of the electricians. Be sure to include labor costs in your estimate to get a complete picture of the overall project cost. Also, research local building codes and regulations. Building codes and regulations can vary depending on the location and the type of project. Be sure to comply with all applicable codes and regulations to avoid delays and penalties. Obtain the necessary permits before starting any electrical work. Permits are typically required for electrical work to ensure that it is performed safely and in compliance with building codes. Ignoring permits can result in fines or legal issues. Be aware of the potential hazards associated with electrical work. Electrical work can be dangerous if not performed properly. Be sure to take precautions to protect yourself and others from electrical shock and other hazards. Wear appropriate personal protective equipment, such as gloves, safety glasses, and insulated tools. Use the right tools for the job. Using the wrong tools can damage equipment or cause injury. Always de-energize electrical circuits before working on them. This will help prevent electrical shock. Test electrical circuits to ensure that they are de-energized before working on them. Use a voltage tester to verify that the circuit is not live. Follow all safety procedures when working with electricity. Electrical safety is essential to prevent accidents and injuries. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment. The NEC is updated every 3 years and is used by electricians, inspectors, and other professionals in the electrical industry. Familiarize yourself with the NEC and its requirements. The NEC contains detailed information on electrical safety, wiring methods, and equipment installation. Understanding the NEC is essential for performing electrical work safely and in compliance with regulations. Article 90. One of the NEC outlines the purpose and scope of the code. It states that the NEC is intended to provide practical safeguarding of persons and property from hazards arising from the use of electricity. Chapter 1 of the NEC covers general requirements for electrical installations. This chapter includes information on wiring methods, grounding, overcurrent protection, and other essential topics. Chapter 2 of the NEC covers wiring and protection. This chapter includes information on conductors, cables, raceways, and overcurrent protection devices. Chapter 3 of the NEC covers wiring methods and materials. This chapter includes information on different types of wiring methods, such as conduit, cable, and surface raceways. Chapter 4 of the NEC covers equipment for general use. This chapter includes information on appliances, luminaires, and other electrical equipment. Chapter 5 of the NEC covers special occupancies. This chapter includes information on hazardous locations, healthcare facilities, and other special occupancies. Chapter 6 of the NEC covers special equipment. This chapter includes information on electric science, electric welders, and other special equipment. Chapter 7 of the NEC covers special conditions. This chapter includes information on emergency systems, standby power systems, and other special conditions. Chapter 8 of the NEC covers communications systems. This chapter includes information on telephone systems, data communication systems, and other communications systems. Chapter 9 of the NEC covers tables. This chapter includes tables that provide information on conductor ampacity, conduit fill, and other essential data. Table 310.15b16 of the NEC provides ampacity ratings for conductors. This table lists the allowable ampacities for various types of conductors based on their size and insulation type. Table 310.16 of the NEC is an important reference for determining the ampacity of conductors based on their insulation type and ambient temperature. It helps electricians select the appropriate wire size for a given circuit to prevent overheating and ensure safe operation. Remember to consult the most recent edition of the NEC for the most up-to-date information. It is crucial to understand how to apply ampacity correction factors and adjustment factors. Correction factors are applied when the ambient temperature is higher than 30 degrees Celsius or 86 degrees Fahrenheit. Adjustment factors are applied when multiple current-carrying conductors are bundled together in a conduit or cable. The grounding system is a critical part of any electrical installation. The grounding system provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The NEC specifies the requirements for grounding electrical systems. Article 250 of the NEC covers grounding and bonding. This article includes information on grounding electrodes, grounding conductors, and bonding jumpers. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level. The NEC specifies the requirements for overcurrent protection devices. Article 240 of the NEC covers overcurrent protection. This article includes information on circuit breakers, fuses, and other overcurrent protection devices. A crucial aspect of electrical installations involves understanding voltage drop calculations to ensure efficient and safe power delivery. Voltage drop occurs when electricity flows through a wire, causing a decrease in voltage from the source to the load. Excessive voltage drop can lead to dimming lights, malfunctioning equipment, and potentially overheating wires. NEC Article 210.19a and FBN 4 recommends that the voltage drop on branch circuits should not exceed 3%, and the voltage drop on feeders should not exceed 2%, resulting in a total voltage drop of no more than 5%. Ohm's law is fundamental to understanding voltage drop. The formula is voltage volts equals current amps times resistance ohms, or volts equals amps times ohms. To calculate voltage drop, you need to know the length of the wire, the current flowing through the wire, and the resistance of the wire. Wire resistance is typically expressed in ohms per 1000 feet. You can find this information in NEC Chapter 9, Table 8, which provides resistance values for different wire sizes and materials. Once you have these values, you can use a voltage drop formula to calculate the voltage drop. A common formula is volts drop equals 2 times K times current times distance divided by circular mils, where K is the direct current constant, approximately 12.9 ohms for copper and 21.2 ohms for aluminum. Current is the current in amps, distance is the one-way length of the circuit in feet, and circular mils is the cross-sectional area of the wire.